This source contains an implementation by Sebastian Igner of a very interesting algorithm. It is the generation of random number following a discrete distribution which surprisingly can be implemented efficiently. The SRFI 27 specification. The following functions are defined in the SRFI specification and are in Perl provided by the random source module. The contract shows here are for documentation purposes only. The PLT scheme implementation of SRFI does not define contracts for its functions. Returns the next number x where x is greater than 0 and less than 1 obtained from default random source. Subsequent results of this procedure appear to be independently uniformly distributed. Default random source. Define the random source from which random integer and random real have been derived using random source make integers and random source make reals. Note that an assignment to default random source does not change the behavior of the random real or random integer. It is strongly recommended not to assign a new value to default random source. Create a new random source. A random source created with make random source represents a deterministic stream of random bits. Each random stream obtained as make random source generates the same stream of values unless the state is modified with one of the functions below. This returns true hash t if x is a random source, otherwise false hash f is returned. Additional random number functionality. The PLT scheme science collection provides additional functionality to that provided by SRFI 27. The current random source parameter. The main additional functionality is to define a parameter current random source that provides a separate random source reference for each thread. The default value for this random source reference is default random source. The use of the current random source parameter overcomes the difficulty with assignment to default random source. However, the routines random integer and random real use the default random source variable and are unaware of the current random source parameter. Gets or sets the current random source. A guard procedure ensures that the value of current random source is indeed a random source as determined by random source, otherwise a type error is raised. Evaluates the body with current random source bound to the random source S. Evaluates the body with current random source bound to a newly created random source. Uniform random numbers. The PLT scheme science collection provides alternative to the random integer and random real functions that are aware of the current random source parameter. They also provide a more convenient interface than random source make integers and random source make reals. Returns the next integer in 0 to n-1 obtained from the random source S or if S is not specified. Subsequent results of this function appear to be independently uniformly distributed over the range 0 to n-1. The argument n must be a positive integer. Returns the next number x where x is greater than 0 and less than 1 obtained from the random source S or if S is not specified. Subsequent result of these functions appears to be independently uniformly distributed. Miscellaneous functions. These functions provides an alternative set of functions to get or set the state of a random state. These functions match the conventions of structure in PLT scheme. This same as random source state ref, the same as random source state set. Random source vectors. These functions provide a convenient method for generating a vector of repeatable random sources. Returns a vector of random source of length n. If I is provided, the jth random source is initialized using random source pseudorandomize Sij. If I is not provided, the ith random source is initialized using random source pseudorandomize Si0. Note that this is not the same as having I default to 0. Example: histogram of uniform random numbers. The following figure shows an example of the resulting histogram. Here is an example for a histogram of uniform random integers. This figure illustrates an example of the resulting histogram. Ruby random numbers. Simply use ranInt. So, if you needed a random integer to simulate a roll of a 6-sided die, you'd use 1 plus ran6. A roll in craps could be simulated with 2 plus ran6 plus ran6. Finally, if you just need a random float, just call ran with no arguments. After that, you can modify the range as you normally would in anything else, that is, using addition and multiplication. In Ruby, how do you generate a random number between 0 and n? In .NET, you can create a random object. Does something like this exist for Ruby? What is wrong with ran range? If you needed a ran integer to simulate a roll of a 6-sided die, you'd use 1 plus ran6. A roll in craps could be simulated with 2 plus ran6 plus ran6. Finally, if you just need a random float, just call ran with no arguments. Ruby 1.9.2 introduces the random class, so while you can still use ran, you can now create your own random number generator objects. It can be marshaled among other things. Available for all versions of Ruby by requiring my backports gem. Apparently, ran is called when the Ruby interpreter is started. Generation of random numbers using C++. C++ standard library for random numbers are namely ran and sran. Ran and ranmax. The C++ standard library includes a pseudorandom number generator for generating random numbers. In order to use it, we need to include the cstdlib header. To generate a random number, we use the ran function. This will produce a result in the range 0 to ranmax, where ranmax is a constant defined by the implementation. Here is a piece of code that will generate a single random number.